Welcome to today's deep dive. I was actually just thinking about this the other day, and I am certain you probably grew up hearing the exact same thing I did.
Oh, without a doubt.
Right. Whether it was your father, your grandfather, or just that trusted local mechanic leaning over a greasy fender, someone in your life declared that buying this specific Japanese compact sedan is the smartest, most financially responsible decision a human can make.
The ultimate smart money vehicle.
Exactly. Before we get into it, please subscribe to our channel. But seriously, the myth surrounding this car is it's a cornerstone of modern driving culture.
It really is.
The idea is so deeply ingrained in us.
Yeah.
You just buy it, you can completely ignore preventative maintenance, and you drive this car straight into the ground. I have always championed it as the gold standard of reliability. It's supposed to be invincible.
I mean, it is a beautiful piece of nostalgia. I will give you that.
Thank you.
And that aura of invincibility was very true back in the late 90s. Those older generations earned that bulletproof reputation through sheer simplicity. But, according to the data I have, looking beneath that bulletproof reputation today reveals hidden maintenance nightmares.
Nightmares.
Yes. The 90s illusion is completely shattered by modern, highly complex mechanical engineering. We are looking at a long list of expensive, long-term component failures that are just silently draining the wallets of unsuspecting owners.
Okay, let's unpack this. Because you are coming after a legend here, and I see these cars everywhere. They seem to run just fine.
On the surface, sure.
Well, if we are talking about modern complexity changing the game, we have to start with how the car actually puts power to the ground.
The transmission.
Right. Specifically, the continuously variable transmission, or the CDT. Now, if you're used to an old school automatic gearbox, you know they use solid metal planetary gears. They are heavy, fixed, and very predictable.
Built like tanks.
Exactly. But this modern CVT is totally different. It relies on a heavily reinforced steel belt sliding between two hydraulically adjustable metal cones to maximize fuel economy.
Right, and the goal there is simple. By constantly adjusting those cones, the engine can always stay at its most efficient RPM.
Like a multi-speed bicycle.
Basically, instead of a chain jumping clunkily from one fixed cog to another, those gears just smoothly expand and contract.
And frankly, I think the engineers were brilliant here with the launch gear innovation.
Oh, the launch gear.
Yeah, because a lot of drivers hate that sluggish rubber band feel of a standard CVT. You press the gas and the car it moans before it catches up. So the manufacturer fixed that by adding a physical first gear purely for taking off from a dead stop.
It does make it feel better.
It totally works. When the traffic light turns green, you get the familiar launch of a traditional automatic, and then it hands things over to the CVT for the fuel saving.
But that exact innovation is precisely where the critical failure begins.
How so? A handoff is standard stuff.
Well, think about what happens in heavy stop-and-go city traffic. The awkward computer-commanded transition between that mechanical launch gear and the sliding steel belt causes huge issues over.
Just from normal city driving.
Yes. You are constantly hovering right at the speed where the computer is deciding whether to be in the physical gear or the CVT belt. Over time, that transition causes bone-jarring shuddering and loud whining.
Okay, but surely a simple fluid change prevents that kind of friction.
And here we get to the dangerous lie of the lifetime fill transmission fluid.
Wait. Lifetime fill.
That's what they call it. It's designed specifically to make the 5-year ownership costs look incredibly cheap on paper.
But fluid doesn't last forever. I mean, internal friction has to degrade it.
It bakes the fluid completely black. If you don't do a drain and fill every 30,000 to 40,000 miles, microscopic metal shavings from that steel belt just
and act like sandpaper.
Worse, they jam the tiny fluid solenoids in the valve body, doing exactly what the manufacturer recommends, which is nothing. Ends up destroying the transmission right around 100,000 miles.
Wow. Okay, if you are enjoying this deep dive so far, don't forget to like the video, comment, and subscribe, because we are obviously just getting started here.
They really are.
Let's move under the hood.
Yeah.
We need to talk about the engine. We're looking at the modern 2.0-liter dynamic force internal combustion engine.
It is quite the piece of engineering.
It is. And even as a staunch defender of this car, I have to admit, this is not the simple, under-stressed engine from the 90s. Note the extreme thermal engineering here. It has a dangerously high 14.1 compression ratio.
Which borders on traditional diesel engine territory.
Exactly. It's an extreme environment.
And that extreme pressure creates intense challenges. To prevent engine knock and carbon buildup, it uses a highly complex dual-fuel injection setup. the D4S system.
Right, so instead of just 4 standard injectors, it uses both traditional port injectors
Spraying the back of the intake valves.
and high-pressure direct injectors blasting straight into the combustion chamber.
That means 8 separate injectors running simultaneously just to keep a small 4-cylinder engine from destroying itself.
Which leads to a really funny, yet terrifying quirk for owners.
The noise.
The noise. When the engine is cold and running those high-pressure injectors to heat the catalytic converter, the car sounds exactly like a broken sewing machine or a small diesel tractor aggressively clattering in the driveway.
It is so loud.
It makes owners panic. They think their engine valves are completely failing on a brand new car.
What's fascinating here is how the pursuit of microscopic fuel efficiency forces engineers to abandon simplicity entirely. Look at the water pump.
Oh man, the water pump.
Contrast the cheap, simple, belt-driven metal water pumps of the old days with today's setup. Today, it's a highly expensive, fully electric motor controlled by the engine computer.
Done purely to squeeze out, what, maybe an extra half a mile per gallon by removing parasitic drag?
Exactly. But the flaw is severe. This electric pump is bolted directly against the incredibly hot aluminum engine block.
Which seems like a terrible place for sensitive electronics.
It is. Over thousands of heat cycles, the internal electronics and the tiny plastic impeller blades bake themselves completely brittle.
So you have fried circuit boards and brittle plastics sitting in an oven.
And then the catastrophe hits. It silently dies, often without a warning light.
No check engine light at all.
Sometimes not until it's too late. The vital pink super long life coolant just stops circulating.
Okay, but if you're on the highway, you have airflow. How much time do you actually have?
Within exactly 3 minutes of highway driving, the engine block aggressively overheats.
3 minutes.
3 minutes. It severely warps the aluminum cylinder head and completely blows the fragile head gasket out the side of the engine.
That is insane. A simple cooling failure becomes a catastrophic full engine rebuild.
All for a microscopic bump in fuel economy.
Here's where it gets really interesting, though. Let's step away from the engine bay, because it's not just the high-tech stuff suffering. Let's look at the basic suspension components struggling on modern, pothole-ridden city streets.
The control arms?
Yes. The front lower control arms use fluid-filled rubber bushings to isolate cabin vibrations, but the thin rubber cares, leaking the dampening fluid out entirely.
Which leads to a very alarming symptom for the driver.
Oh, absolutely. Lightly tapping the brakes causes a severe metallic clunk echoing through the floorboards, and the steering wheel aggressively jerks to one side.
Because the front wheel is flopping around unsupported.
Right. The car literally feels like it's falling apart.
And the exterior isn't holding up much better. The incredibly fragile exterior paint quality is a direct result of modern environmental regulations.
A water-based stuff.
Yeah. It uses thin, water-based paint, a soft, eco-friendly clear coat, and an extremely thin primer.
I've noticed you barely have to touch these cars to scratch them.
The real result is seen when driving behind heavy transport trucks. It instantly peppers the sloping hood and plastic bumper with deep stone chips,
Which exposes bare metal to harsh winter road salt.
leading to rapid rust.
It's heartbreaking. And the interior isn't spared either. They cut budgets on the interior materials. You get this hard, scratchy plastic dashboard and door trim panels.
Which do not handle temperature changes well.
Not at all. They expand and contract in extreme heat or cold. They rub together to create a maddening, non-stop symphony of high-pitched squeaks and loud rattles right next to the driver's ear.
So much for that premium, quiet ride.
So what does this all mean? As the guy who always defended this car, I'll admit, the absolute core engine block might theoretically last forever if properly lubricated, but the modern reality is far more complicated.
It is. Keeping these highly stressed, complex auxiliary systems functional requires an extreme level of strict proactive maintenance.
You really have to stay on top of it.
And it requires a total rejection of the incredibly dangerous lifetime fluid myth. You cannot just drive these cars into the ground anymore.
Before we leave you to think about all of this, please subscribe to our channel. We really want to leave you with this final thought.
It's an important one.
If car manufacturers are engineering auxiliary systems to be this fragile just to hit microscopic fuel efficiency and eco-friendly regulations, at what point does the massive out-of-pocket cost of repairing these complex components completely outweigh the savings you get at the gas pump?
That is the real question.
Think about that trade-off the next time you're car shopping. Thanks for joining us today.